All right. Well, 12:02 here. I'm gonna kick this thing off. I'm sure we're gonna have some more folks join us. Um, but we'll just get rocking and rolling here. So, my name is Michael McCarty. You are in a presentation for the Walking Working Surfaces update and preparing for 2036 ladder updates that are coming down the pipeline from OSHA. So, just a few housekeeping things. This is a half-hour presentation. Generally, I like to leave a lot of time for questions towards the end, so I'll leave at least 5 minutes, hopefully seven, eight, nine. Tends to be a lot of questions with ladder and these interpretations. If you have any questions, feel free to just pop them in the chat as they come to mind. I don't want you to forget questions. We have some people monitoring the chat, so we can address those questions towards the end. And if you are an architect or you're looking for AIA continuing education units, feel free to email me after this, and we'll make sure you get credit for this. So with that, we will get going. And talking just real briefly about myself, so I'm Chief Safety Officer here at Edge. If you do want to connect with me, that QR code's in the corner of your screen, so feel free to do that. Edge Fault Protection, we're a turnkey fault protection provider. We work across the country. We design, we engineer, we procure, and we install fault protection solutions and access solutions across the country. So if you need help with all of those things or you need help with just one of those things, we're happy to help you out if we can. But primarily our specialty is really rooftop fault protection solutions, although we do more and more and more inside facilities and in manufacturing settings. So for today's agenda, just going to talk about regulating agencies briefly, get us all started on the same square, ladder code updates, ladder safety challenges, what we're seeing in the industry, practical compliance solutions, and then that Q&A. So starting with important safety codes, we really have two regulating agencies that we're working with. We have OSHA, which is run by the Department of Labor. OSHA is the governing body that enforces regulations to keep workers safe. That's in contrast to ANSI, which is a nonprofit organization. It's really a North American standard. And these are really people from the industry, people like myself and other manufacturers, integrators, fall protection experts, who are taking the OSHA standards regulations and applying them in practice and creating a couple other voluntary safety standards and protocols to make sure that what OSHA says can be applied in best practice. As far as the two regulations that guide fall protection, we are looking at OSHA 1910 subpart D. So 1910 is the subpart of OSHA that requires employers to provide fall protection to all employees exposed to fall hazards. The other piece of OSHA that's not listed here, OSHA 1926, same fall protection requirement to protect employees who are exposed to fall hazards, but 1926 is specific for construction, where 1910 is general industry. We'll focus on 1910 today, but just wanted to inform you there's another one out there as well. ANSI Z359, that's outlines the proper training, is required to inspect, use, store, and maintain fall protection equipment. It also guarantees that engineering of fall protection equipment, including on ladders, is safe and sound. More specifically, we'll get to that in a second. So ladder code updates. I do have a question for each of you. There should be a survey that pops up for y'all. But what type of fall protection do the fixed ladders at your work site use? So a couple options here. Personal fall arrest system, abbreviated as PFAS, cages, probably the most common out there. Don't have ladders where you work, or we have ladders but don't use any sort of fall protection. I'm going to take just a few minutes to get some feedback there. We have only one person here that has personal fall arrest systems, so PFAS systems. Some using cages, some don't have any ladders at all, and then some having ladders without fall protection. So hopefully we can address pretty much all of these people. All right, so updates OSHA 1910.28. So as of November 19th, 2018, cages are no longer considered an adequate form of fall protection. So prior to this rule, any ladder that was over 20 feet required a cage. And then any ladder that was, we need a rest platform every 30 feet. Now, all fixed ladders extending over 24 feet must be equipped with a personal fall arrest system. So it went from 20 feet where you required anything over 20, you needed some cage. Now anything over 24 has some sort of personal fall arrest system. And so then the final piece here is any ladders installed after 2018 must meet the new regulations, and ladders installed prior to the change must be replaced or updated by 2036. So just as a timeline here to reiterate what I just said, pre-2017, cages are considered compliant. That's the standard practice. The thing is that OSHA looked at all of the data and said, hey, these cages are providing a false sense of security. They don't effectively prevent falls. What happens is a user may slip, trip, or fall down a ladder, and then they're kind of getting banged up in the cage on the way down, and then they still hit the ground. So they aren't stopping the falls. They aren't preventing the falls. They're still injuring employees. So what they did is 2017 updates that final ruling 1910 subpart D. Again, as I mentioned before, any new ladders over 24 feet require fall arrest systems, personal fall arrest systems. I've reviewed a ton of specifications, a ton of drawings over the last many years that are still including cages. So there's kind of a vacuum of information and practice that says that architects and engineers just don't quite know that any of these ladders over 24 feet need fall protection, not those cages. So we still get requested to build those quite often. And then kind of the deadline to implement this is November 18th by 2036. All fixed ladders need to be transitioned to the personal fall arrest system. So we have 11 years here to make sure that any ladder over 24 feet has some sort of personal fall arrest system on it. So I kind of alluded to this, but the question we have here is, have you or someone you know experienced a ladder-related injury? Just provide a few seconds here. Okay, so some people on this call, on this webinar, have personally experienced a ladder-related injury. 36% know someone who has, and about half don't know anyone that's had an injury yet. And hopefully it stays that way. So just some quick numbers for you. Ladders are dangerous. When I'm communicating with people on sites or on the phone or whatever, I'm always emphasizing that your transition points on the roof, off the roof, on the platform, on the mezzanine, and off, those are your most dangerous locations. So it is easy to slip or have your hand slide or not be wearing gloves when you should, and the steel that you hold on to with the ladder has some sort of abrasions, and you release and you fall. So roof hatches, ladders, anywhere where you're exposed, very exposed to heights, are places where you really need to be particularly careful to make sure that you don't fall. So as far as top safety violations, In 2024, ladders accounted for 2,500 OSHA violations. In 2020, we get these numbers from the Bureau of Labor Statistics. 2020 is the most recent data that we have. Ladder incidents caused 22,000 non-fatal injuries, 610 people died, 130,000 emergency room visits, and 24 billion in expenses. Those are all very big numbers. So this kind of demonstrates why OSHA prioritized ladders to say, hey, these are a real problem. Companies and insurance companies and people are experiencing major expenses. People are dying, and then non-fatal injuries, which could result in some serious repercussions for the rest of your life, are really significant. So we want to reduce these as much as possible. Moving on to practical solutions, there are a number of different ways to implement a personal fall arrest system. What is a personal fall arrest system? If I haven't touched on this, it's a system an employer uses to provide protection from falling or to safely arrest an employee's fall if one should occur. So any personal fall arrest system includes three components. It has an anchorage, it has body wear, which is a harness, and then it has a connector. That connector is usually a lanyard, typically a lanyard. Three main types that we use. Self-retracting lanyards. So we can install, engineer a davit crane or some sort of hanging piece of steel above a ladder. And then a user would pull the snap hook from the SRL down, clip up to their dorsal D-ring, and then they can ascend and descend the ladder hands-free. A rail-based system, so that is usually a continuous run. That's going to be mounted to the rungs of the ladder. It's going to be a continuous run up and down the ladder. Anytime you're climbing up and down these rail-based systems or a vertical lifeline system, you're going to need a chest D-ring on your harness. So almost every harness has a dorsal D-ring. Many of them do not have a chest D-ring. So if you're looking at these different systems, make sure you're also updating your B body wear or harness to make sure that people can actually use the systems that you install. Of the three of these, there are different complexities in each scenario. The vertical lifelines is definitely the most common. It's the most cost effective, but it has some limitations. The rail-based system, the continuous system, that is a little better for aluminum ladders because those rungs are usually hollow, and in the event of a fall, those rungs can collapse. So you need a system that spans the length of that and has more connection points. And then a self-retracting lanyard, I think, is a great option, but sometimes difficult to engineer, sometimes impossible to put the equipment overhead to be able to use. So additional considerations for personal fall arrest. Anchor points. This is probably the single biggest thing that is being overlooked when I have conversations with architects and engineers is that when we are thinking about this anchor point, which is our vertical lifeline system, our rail-based system, or the davit that is overhead that connects to the SRL, we have to think about where those loads go. So we have a vertical lifeline on the ladder. A fall occurs. So that load is going to transfer to the rungs. It's going to transfer to the stringers, and then it's going to transfer to the structure. So how is that ladder attached to the structure? How is it attached to the substrate underneath? Is it bolted, welded? Is it is it tech screwed into some aluminum studs? Some of these are going to be robust enough to absorb those loads. Some of these are not. So making sure that whatever fall protection provider that you provide, that you get a comprehensive solution built and in place here, because you don't really want to buy a product right off the shelf and just install it without verifying that your structure, your ladder, can absorb the loads in the event of a fall. We do the engineering. Again, we do the we do the design. So we can help here. Generally, in my experience, it's best if you get an engineer of record involved into any sort of structural analysis that you're doing. Our engineers can always provide that information to the engineer of record, but usually it's most cost advantageous to have the engineer of record actually sign off on the loads that may be transferred into your building envelope. So person fall arrest pros, we do have multiple options, can be added to pre-existing ladders, and it definitely provides a lot of mobility for workers. So it is a hands-free option. Cons definitely requires additional training. This is a new system that's being rolled out across the country. And again, we have 11 years to comply with this. The sooner you can do it, the better, so you can get your people trained up and get the processes in place. Another con requires additional time for inspection, application of safety gear. So if you have a ladder over 24 feet, you're now kind of forced to use active fall protection, this personal fall arrest system. Whereas before, maybe you didn't need to use a harness in your workplace. And that can be a really good practice in a lot of applications if people don't have to use active fall protection. Another con, ladder might need to be replaced if it can't support the load of the fall. So that's a reality that we need to look at, think about, that says, hey, yeah, we can do the design, we can analyze the structure, but it might be a no, and we might have to get a new ladder or transfer to a different system. So this kind of dovetails into this next thing that we can do. We can switch to stairs. So we can get rid of ladders and we can switch to stairs. A lot of benefits here. It's going to increase safety and stability, better load carrying capabilities, reduce worker fatigue, improve accessibility, easy egress in emergency situations. It is not cheaper by any means. Switching to stairs is almost always going to require some engineering, and it's going to be more expensive because it's more steel. Maybe we're adding concrete to, or adding some sort of maintenance pad that we need to do. It's just a lot more robust. But I think one of the other big benefits of a stair, besides we don't have to use an active fall protection scenario, is if you have an environment where you need quick egress from your structure. Think about a food and bev facility that has ammonia pipelines and you have a leak up there. You want people coming down from that elevated surface as quickly as possible, as opposed to transitioning from the roof level at the highest to the second highest to the third highest to the ground. That can take a minute if we have to use any sort of personal fall arrest system. The other thing here that we talk about a lot at Edge is just the hierarchy of fall protection. We think about how we should think about fall protection. Number one, we should eliminate the hazard if at all possible. And number two, we try to use passive fall protection, so guardrail, stairs. This is more advantageous, more effective than fall arrest or fall restraint, and a personal fall arrest system is a fall arrest scenario. So staying in the top two brackets of that is always going to be better for the user and the employee. This is just a quick slide covering the OSHA design and installation requirements of stairs. So they're all going to have guardrails. They're going to meet the standards that they need to meet. It does need to bear at least 5 times the live load. Again, pros and cons. Pros, easier to use, require little to no training. You could look at the long-term economic benefits, less OSHA violations cited, less risk of an injury or settlements. Maybe your insurance premiums go down. I mean, the biggest pro is that it's a lot less likely that you're going to have an injury. And then some of the cons, it definitely requires a lot more space than ladders. So it's just not practical in a lot of situations. And as I mentioned before, it's a much greater initial investment than adding a personal fall arrest system to existing ladders. Great. So what kind of questions can I answer for folks? I think Colton was monitoring our questions. So if you want to pop on, Colton,
we've got no questions at the moment. So if people want to get some questions in, but some common ones that we kind of talk about on the webinar is, transferring between two different ladders and how those work. If you want to talk about that briefly.
Yeah, of course. So oftentimes you have ladders that are tiered, right? Or offset. So you go up 30 feet, you transition to a platform, you go up another 30 feet. So we have a vertical lifeline system. We can design systems that creates a fluid transition. So we move the cable up, we put a bend in the cable through some brackets, and then we're continually going up the vertical lifeline via a ladder.
Awesome. And we do have one question now. Is there any requirements for ladders between 20 feet and 24 feet?
No requirements. Yeah. So you will have cages on, let's call it a 22-foot ladder. You probably have a cage on it. You don't need to remove that cage. You can just keep it on there. That 22-foot ladder is compliant now, and it's compliant after 2036. So you don't need to make any changes. If I didn't answer that correctly, please let me know.
And then a follow-up question on that. Are cages required at 20 feet?
Cages are not required at 20 feet. Yeah, so for any new ladders over 24 feet, cages are never required. But any ladder over 24 feet needs a personal fall arrest system. And previously, it was any ladder over 20 feet needed a cage, but not anymore.
Awesome. We got another one here. Are cages required to be removed on existing ladders prior to 2036?
Great question. You do not need to move or remove the cage. You can keep it on your ladder. Let's say you have a 28-foot ladder, has a cage on it already. You can keep the cage on it. You need to add a personal fall arrest system to that cage. So the caveat to this is the caveat is if the user needs to be able to go up and down the ladder easily with the cage in place and with the vertical lifeline system or personal fall arrest system. So that personal fall arrest system, it does take up some real estate on you have your ladder rungs, and then you have the cable systems or the rail-based system. And then you have your cage, which is sometimes already a tight squeeze. So if you put that personal fall arrest system on a ladder and you can't freely go up and down the ladder, then you should remove the cage.
Awesome. No other questions at the moment, but do you want to just talk about like what's required once you get, you're going up the ladder, you're getting close to the top of the roof. What kind of additional fall protection is needed? We run into a lot of different situations where there's, a ladder up to the roof, but there's nothing once you get up there, as far as that immediate spot that you're standing when you get off the ladder.
Yeah, thanks. There should be some sort of transition point there. Generally, and I'll just use specific examples. If we're coming up a roof hatch onto a rooftop, we're using that vertical lifeline or rail-based system or have an overhead SRL. What we almost always provide is a roof hatch guardrail on that hatch to make sure that the transition from the ladder to the rooftop is as safe as we can make it. So maybe we have the chest D-ring, dorsal D-ring. We go all the way up. We're going to put some sort of anchor on the top of that ladder. We would hook onto that anchor with a SRL that's generally attached to our dorsal D-ring. We'd kind of walk around that hatch and then we can unhook from that anchor. And now we have an open hole, which is the hatch, but we're in a safe area because we provided that guardrail. So again, it's part of a system. We need to think about what is the use case here. Using the cookie cutter approach of grab something off the shelf and throw it up. It'll work in some scenarios. Most of the time it will not.
Awesome. I don't think I have anything off the top of my head right now. If anyone else has any questions, get them in. Otherwise, I think that's all we got.
Okay, awesome. Well, thanks for everyone's time. You should get a recording of this after the fact. If you want to connect with me, shoot me an email. Hopefully that QR code goes to me. But thanks for joining us today and have a great rest of your week. Oh, I did have one more question that I'll just answer. Is there still a requirement for rest landing? Yes, there is. It used to be every 30 feet. Now it's every 150 feet. So you can use some sort of personal fall arrest system, all the way up to 150 feet. Beautiful. Have a great week, everyone. Take care.